Hey guys, welcome back. Today we're going to deal with trig functions on the unit circle. So there is a limitation of trig when using a standard right triangle, and that is that theta, an angle measure, must be greater than 0 degrees but less than 90 degrees. So when we put that on a unit circle, we can have an angle formed anywhere on this circle. So because of this limitation, trig functions always use the triangle formed with the reference angle. Okay, so you might have a rotation of a ray right to about here. Okay, so that would give us a triangle right there, a nice neat right triangle. This length right here would represent the x value, this would represent the y value, and there's the radius. Now this is in a coordinate plane. The unit circle is always in a coordinate plane, so that point right there is going to be some x, y coordinate. But what if you have an angle that rotates out to here? Now we're more than 90 degrees. Well, then we use this reference angle right here. Okay, and we make a triangle out of that. So we're still between 0 degrees and 90 degrees. In this triangle, the hypotenuse is always going to be the radius. The radius is always going to be considered a positive value. No matter what quadrant it is, that will always be positive. Now from this angle right here, we'll call that theta. The opposite leg is the y value. And the adjacent leg is the x value. The x and y values can be positive or negative. Okay, so for x values, left would be negative, right would be positive. For y values, up is positive, down is negative. So in a unit circle, a triangle on a unit circle, the sine value, sine is opposite over hypotenuse, opposite is the y value, hypotenuse is the radius, so that is the y value over the radius. Cosine adjacent over hypotenuse, adjacent is the x value, hypotenuse is the radius. And tangent is opposite over adjacent. Opposite is y, adjacent is x, and we can look back at this picture here as well. Opposite is y, adjacent is x, hypotenuse is the radius. So tangent is y over x, opposite over adjacent. Then we have cosecant, secant, and cotangent, and remember those are reciprocals of sine, cosine, and tangent. So cosecant is r over y, secant is r over x, and cotangent is x over y. So we're going to use that information to find the 6 trig values, sine, cosine, tangent, cosecant, secant, cotangent. We're going to find the values of the 6 trigonometric functions for angle theta in standard position if a point with the given coordinates lies on the terminal side. So here's what that means. The point 3, negative 4, and that's right here on this circle, 3, negative 4. We're going to turn that into a triangle. So there's a reference angle right there, and we'll make a right triangle out of that. So that means it's over 3, so that is your x value. It's down 4, so the x value is 3. Let me change that x to a 3. And the y value is negative 4, because it is down 4. Now in order to do all the ratios, we need opposite, adjacent, and hypotenuse. So we're going to need to know the length of that radius. So 3 squared plus negative 4 squared equals c squared. Okay, so that's 9 plus 16, so that's 25 equals c squared. and then the positive square root is 5. So the length of the hypotenuse, or the radius, is 5. So sine theta, and there's our theta right there, that reference angle, is opposite over hypotenuse, which is the y value over the radius, -4 over 5. Cosine theta is adjacent over hypotenuse, which is x over r, 3 over 5. And tan theta is opposite over adjacent, which is y over x, which is -4 over 3. Okay, then the reciprocals, cosecant theta is the reciprocal of sine theta, so it's 5 over -4. Secant theta is the reciprocal of cosine theta, so that's 5 over 3. And tan theta, cotangent theta, is the reciprocal of tangent theta, so that's 3 over -4. 0, -5, it's going to be awfully hard to make a triangle out of that because it just goes straight down. So no triangle here, but we can still get all 6 ratios. So sine theta, sine is opposite over hypotenuse. Now we really have to think in terms of x, y, and r. So if we look back here, opposite over hypotenuse was the y value over the radius. So here, the y value over the radius. Well, the y is -5. Let's make a note here. The x value, the y value, and the length of the radius. The x value is 0. The y value is -5. And the radius is that length, which happens to be 5 units. Radius is always positive. So sine was opposite over hypotenuse, which was y over r. Y over r is -5 over 5, which is -1. Cosine theta, back here in the first one, is adjacent over hypotenuse, or x over r. So it's the x value over the radius, 0 over 5, and that's 0. Tangent theta is opposite over adjacent, that's y over x. Y over x is -5 over 0, and division by 0 is undefined. Okay, then we go to the reciprocals. Cosecant theta, the reciprocal of sine, so that's 5 over -5, which is -1. Secant theta is the reciprocal of cosine theta, so that's 5 over 0, which is undefined. And then cotangent theta is reciprocal of tangent theta, so that's 0 over -5, which is 0. All right, so the unit circle. Unit circle is a circle placed on a coordinate plane, and the center is always at the origin. So the center is always 0, 0. And we used a couple circles here on the previous page. So these are circles on a coordinate plane, but they're not exactly unit circles because both of them had a radius of 5. In a true unit circle, the radius is 1. That would be 1 unit. That's why it's called a unit circle. Its radius is 1 unit. So in a true unit circle, so you've got some point x, y. That means it's over x units and up y units. And that radius is 1. Sine is opposite over hypotenuse. So there's your theta, there's your right angle. So that's y over 1. So in a unit circle, the sine value is the y value. The cosine value in a true unit circle is x over 1, or x. And tangent is opposite over adjacent, y over x. So there's going to be some times doing trig when a unit circle is appropriate, and sometimes when a circle with a radius other than 1 is appropriate. So a 30, 60, 90 triangle and a 45, 45, 90 triangle. We're going to fit those into circles on the coordinate plane. So a 30, 60, 90 triangle is half of an equilateral triangle. So we've got a right angle there. This is 60. An equilateral triangle has 3 60-degree angles, but it's cut in half. So it's got a 30-degree angle here. Typically, we've learned of that in the ratio of 1 to square root of 3. Now this hypotenuse would be the radius, so if I put this into a circle, it's not actually going to be a unit circle because it's going to have 2 units for the radius. If I actually wanted that to fit a unit circle, then I would have to make the radius 1. Now the radius is twice as long as the hypotenuse is twice as long as the shorter leg, so that means in this case the shorter leg would be 1/2, and this longer leg would be 1/2 times the square root of 3, or root 3 over 2. This is what it looks like if it's going to fit the unit circle, but 1, 2, root 3 is easier to remember. Similarly with 45, 45, 90, a 45, 45, 90 triangle is half of a square. So all the angles are 90 degrees. Cut that in half and I get a couple 45-degree angles. We've learned of that typically as 1, 1, and square root of 2. But if we actually wanted that to fit the unit circle, we would have to have a radius of 1. So the hypotenuse would have to be 1. Which means this would be 1 over the square root of 2, or root 2 over 2. Okay, so the first one of each is easier to remember. The second one of each actually fits the unit circle. There's going to be times when it's appropriate to use either one. Trigonometric functions are simply a ratio of sides, so it really doesn't matter which of these triangles we use out of the 45, 45, 90s, or which of these two we choose to use, because a ratio, whether it's simplified a certain way or not, has the same value. Doesn't matter which way it's simplified. So, use the unit circle or special right triangles. So if we're going to use special right triangles, we're using these. If we're going to use unit circle, we're going to use these. Sine of a 60-degree angle. So a 60-degree angle would look about like that. Okay, and I'm going to use a unit circle. I'm not going to use a unit circle. I'm going to use a special right triangle because it's easy for me to remember 1, 2, square root of 3. The sine value is opposite over hypotenuse, which is the square root of 3 over 2. Okay, so the sine, by the way, is the x value, so the coordinate right here, it's the y value. So the y coordinate right here would be square root of 3 over 2. Cosine would give me the x value, and that's adjacent over hypotenuse, so it would be 1/2. That would be my x value. Next is cosine 225. And 225 rotates past 180, right about there. And we're going to turn that into a triangle, but we need this reference angle measured. So that's 225 minus 180, and that's 45 degrees. So what I have here is a 45, 45, 90. Okay, and I'm going to use the special right triangle again, rather than a unit circle because the special right triangle is just easier to remember. So special right triangle, 45, 45, 90 is 1, 1, root 2. But notice we're going left here, so that's actually negative 1. And going down is negative 1. The radius is always a positive number. So now the cosine is the adjacent over the hypotenuse. 1 divided by square root of 2. Now we do need to simplify that with no radical in the denominator. So we'll multiply numerator and denominator by the square root of 2 and get negative square root of 2 over 2. And now cosine is an x value, so negative root 2 over 2 is the x value. The y value would be sine, which would be actually the same value here because opposite and adjacent are the same, so it's going to be negative 1 over root 2. So the y value here is actually root 2, negative root 2 over 2 as well. The next one is sine of 180. 180 rotates right there. Okay? This one does not give me an opportunity to draw a special right triangle, so I'm going to make this one a true unit circle, radius of 1. Which means that the coordinates here are going to be negative 1, 0, left 1, and up 0. So the sine value is opposite over the hypotenuse, which is the y value over the radius. The y value here is 0, so it's 0 over 1, which is 0. So really the sine value is just the y value. So our sine of 180 is 0. Secant, negative 90, that's going to rotate clockwise 90 degrees because it's negative. It'll rotate to right there. Once again, I can't draw a triangle, so I'm going to use a unit circle. Radius is 1. This is over 0 and down 1. Secant is reciprocal of cosine, so I'm going to make a note. That's 1 over cosine theta. Cosine is adjacent over hypotenuse, and if I look back up here, adjacent seems to come from the x value. So since it's the reciprocal, it's actually going to be hypotenuse over adjacent. So it's adjacent down there. Hypotenuse is the radius. So it's the radius over the x value, which is 1 over, and the x value is 0. So secant negative 90 degrees is undefined because it's divided by 0.